Here we go. Is the water boiling yet?
Sort of.
How about now?
No.
How about now?
Well, are you watching it?
It won't work if I'm watching it. Oh, I can only draw my ramps in one direction. I don't know why.
One direction.
Not the band. Box on a ramp, Kenley. Box on a ramp. So obviously there's weight straight down, right? What other forces do I know? If it's frictionless, the only other force in here would be force normal. If there is friction, the box would want to go down the ramp, so friction would oppose that motion and would point up the ramp. Yes? Force of friction. That's supposed to be parallel to the ramp, by the way. All right, so those are the three main forces acting on the system. If I define positive as the direction of presumed motion, which seems reasonable that the box would go down the ramp. Positive, let's define positive as down the ramp. And then, of course, remember I have to decompose. This mg is the hypotenuse of a right triangle. The right angle is here, and this angle is theta. And I've told you why that's the case. If you don't remember, I don't care. Just remember that that is theta. Got it? Well, I've told you, right? So, positive mg, this is parallel to the ramp, mg sine theta, that's positive, minus force of friction equals ma parallel, the acceleration parallel to the ramp. If it's not moving, trick question. Not really a trick, but testing you. If it's not moving, what kind of force of friction am I working with?
Static friction.
Static friction, mu sub s. And what would be on the right-hand side? 0. Right? If it's not moving? If it's not moving, the force of friction is exactly enough to keep this piece of gravity from moving it down the plane. This would be 0. And the mu that I would use there would be mu sub s, static, not moving friction, which is always bigger than mu sub k, moving friction coefficient. However, it's best you do this to account for all contingencies, right? Now, perpendicular to the plane, I've got up. I'll define this direction as positive for the perpendicular direction. Maddie, are you okay? You look sad. Okay. Force normal minus mg cos theta. That way equals what?
Equals 0.
Is the box going up or down?
Well,
It
how
must
do
be
we-
balanced.
Might be levitating.
It might be if there's like maybe a magnetic force there or something, right? Potentially. But there isn't. This is physics 1, right? Is this hot?
I've done that before.
Oh my gosh, so on this thing last year, I was just failed in.
Nice.
No, I'm just kidding. All right, so is everybody comfortable with these equations?
Yes.
What's force of friction equal to?
Aha! Force of friction. There's another definition of it, right? It's mu force normal. So if I write this mg sine theta minus mu support force equal ma parallel. And if I look at the second equation, That is true. Is it not, James? James?
It is true, yeah.
Thank you. So what do I do with this force normal?
You isolated it.
I did. What do I do with it?
Oh, when you.
Plug it in.
Put it right there.
Yeah.
So mg sine theta minus mu mg cos theta equals ma parallel. And lo and behold, the mass makes no difference whatsoever.
Shocker.
You guys see that? So if you're ever given a problem on an exam where they don't give you the mass and you think you need it,
You don't
check your
need
work
it.
again.
I'm sorry, I'm
You
sorry.
might be missing it, or the teacher screwed up. It happens.
It's like.
Don't need it.
I zoomed in, your hand didn't get in. I'm gonna get like her hair.
All right, so that's there. It's done. Now, listen. Once you know the acceleration, if this thing started at rest, could you figure out how fast it's going at the bottom?
Yes.
Using
Kinematics.
kinematics. So make sure on your 5 sides of an 8.5 by 11 that your kinematics are on there.
Yes.
And it's not kinematics in the x direction or the y direction. It's kinematics parallel to the ramp. It's the same formulas. It's just like this. You don't have to do anything special. Use the same formulas. You know A. You might know V initial. You might have to find V final. You might need a distance to do that, or you might have to find the distance. You know, kinematics. Check.